Hello everyone, this is lesson 4.6 extension, linear regression and correlation coefficient using your graphing calculator. So first thing I need you to do is to make sure that your calculator is out and ready to go, your graphing calculator. You can't just use a regular like scientific calculator, you need to have your graphing calculator for this one. And also you won't be able to use Desmos because the commands for your graphing calculator is different than Desmos. So we're going to learn basically what we did in Desmos, we're going to learn how to do it in your graphing calculator, which is a lot different, but it's still important to learn because you're going to be using your graphing calculator all throughout the rest of high school and college. So the first thing you're going to need to do, also this worksheet here, this 2-page worksheet, you can also find in the Polaris folder for today. So the first thing that you'll do is, also one other thing. If you are an in-person student today, you do not need to watch this video because we're going to go over this in class. So sorry, I know there's some times where we'll have to make the video for the e-learners, but we go over it in class, so you don't have to do it if you're in person. And sometimes I forget to mention that, but you don't have to watch this if you're in person today. So I will give you the points for that. So anyways, this worksheet is in the Polaris folder if you want to print it off or make a copy of it, whatever, but it is very important that you have these steps written down somewhere. So if you're not going to make a copy of it, then write it down on your notebook. All right, so the first thing to do to perform a linear regression basically means to make a line of best fit. So we're trying to do a line of best fit, like y equals mx plus b, based on data that doesn't always exactly fit the line. That's what the correlation coefficient is for, to tell us how closely the points are to that line of best fit and how correlated the data is to a certain trend, positive or negative, or strong or weak correlation. So first, what you're going to do is make sure that your diagnostics on is on. You only need to do this once. So sometimes it might already be on, but the only way to check is to get your calculator, and I will try to make this bigger. We'll just do full screen. Okay, so you're going to go to catalog. Actually, I kind of want to see what we're looking at here. Okay, so it says to go to catalog, diagnostics on, and it's alphabetical, so you have to scroll down. So the catalog button is right here. So you'll click second, 0, and then you see how it's in alphabetical order. You'll scroll all the way down, and I have to do it one by one, but you can just hold down your down button arrow until you get to D for diagnostics. Okay, so here it is, diagnostic on. Now press enter, and then press enter again until you see done. Once you see done, then you're done with step 1. Also, I'm wondering if I can make this. There we go. Okay, so second is to make sure that your plot 1 is turned on. So to do that, you go to y equals, so the steps are right here, so follow along with me. Part A of the steps is to go to y equals, and then if there's anything there, you can just clear it out. Important to not press delete, but press the clear button. And then you see how plot 1, plot 2, and plot 3 are unhighlighted. That's generally what you want, except for if you're working with statistics. So if you're working with statistics and you're working with your plot 1, that means you're like scatter plot 1, then you want to go up to it and highlight it. To highlight it, you just press enter. Okay, so and to scroll up, you just use your up arrow. Okay, so now it's highlighted. If I press enter again, I unhighlight it. If I press enter again, it's highlighted. If I scroll down, I can double check that it's highlighted. All right, so we're done with this step. We're also done with this step. Okay, we did that. Now, enter your data. So to enter your data, I'm going to give us like just a random set of data to do for this primary example. You'll go to Stat, Edit. So the Stat button is right here, okay, right by the left arrow, Stat. And then Edit is right here, this first option. You're going to press Enter. Now here you see all of your lists. This is where you type in data. So we're going to type in some numbers into list 1 and some numbers into list 2. We'll just go 1, 2, 3, 4, 5 for list 1. And this is just random data. So 1, enter, 2, enter, just like that. And I'm going to arrow over. Now, one thing that's important, if you ever want to clear your list, you can go up to it and press clear. Okay, this button right here. Don't press delete because that'll delete the entire L1 column and then it'll start with L2 and then you'll have another problem. Also, if anytime you are unsure of what's going on in your calculator, like if it's not doing what my calculator is doing, then just send me an email or ask me if we could do a quick Google Meet to go over what's on your calculator. It might be helpful if you take like a picture of what your calculator is saying. So anyways, now let's type some data into L2. So I should have the same items in L2 as it are in L1. If they don't match up, that means that I must have forgotten something or added something extra. So let's do 5 numbers in L2, and they can be any numbers. How about 20, 26, 30, 22, 45. All right. So now that we've done that, so we enter X into L1 and Y into L2. So this is like our X and that's our Y. If something is already there, go up to L1 and L2 and clear it. Okay, and then we set a good window. So remember how we did our window setting in Desmos? We clicked on the gear symbol and set the window. Well, we're going to do something a little bit different here. We're going to click on window, and then the X, min, and max are the same thing. So for what you were working with, we went from 1 to 5. So we'll go just from 0 to 10. So 0, X min, X max is 10, scale of 1 is fine. And then for the Y's, we went from 20 to 45. So maybe we'll do, how about just 0 to 50? Okay, it doesn't have to be exact. Just make sure that you capture all of the data. And then maybe in increments of 2, just so it's not so cluttered. That just means instead of 50 tick marks, we only have 25 tick marks because we're only going in 2s. All right, so once you have that, it says to press graph. Do not press zoom 6, which I haven't taught you that yet anyways, because that'll just undo your window settings. Because originally it was -10 to 10, -10 to 10. That's your standard window. But if you want something specific, then you can set it like that and then press graph. All right, so we see our points here. So now we see our scatter plot. Great. So we are actually done. We did this step. We did that step. We're done with part 1. Now for part 2, kind of the more important part is to create the line of best fit. It's nice to get a scatter plot, which will be useful for other things. But for now, we're going to make your line of best fit. So now that you're here, you want to go to the home screen. So to go to the home screen, you'll press second quit. So second mode button. And then you're going to press stat. And then instead of edit, you're going to go to calc. So click on the stat button and go over to calculate. And then you're going to choose option 4, lin reg. So see how it goes like 1 variable statistics, 2 variable statistics. Those are not things you need to worry about right now. And then here, quadratic, cubic, quartic functions. And then these are just different forms of a linear regression. We're going to do just the regular mx plus b, but instead of m, they use the variable a. Okay, so it means the same thing. So go to the 4th option, or you can just click the number 4. And then it'll say, okay, I want my X to be list 1. I want my Y to be list 2. It should always be like that, L1, L2. If it's ever mixed up, then just replace it with one of these L buttons down here. Here, if you don't use L1 and L2 column, maybe you typed it in L3 and L4, then you would put L3 and L4 here. But if not, then just know that it should be L1 and L2. You can skip these things. This store button is something special that we might look at later, but in the meantime, we're just going to skip this part. and then press calculate. All right, so now it gives you the same thing that the Desmos calculator gave you. It gives you the slope, 4.6, the y-intercept, 14.8, and the correlation coefficient, 7.3. So I'm going to put all that down on my paper here. So the equation then would be y equals 4.6x plus 14.8. And then the correlation coefficient. So usually your m and your y-intercept, you're gonna round to 2 decimal places. But then your r value, you're gonna do to 4 decimals. Actually, hold on a second. What did I say here? Write down the equation y equals ax plus b using 4 decimal places to round. I'm sorry. Well, let's just stick to 4. So round everything to 4 decimal places if needed. If not, then you just do what's there if it's just to the 10th place. So we'll do 0.7317, 0.7317. Make sure, please, that if this was a number greater than 5 or greater, then you would round the 7 up to an 8. Okay, some people still are not doing rounding directions properly. Okay, so now you would describe the correlation. So I would say that this is definitely positive correlation because it's plus and it's going up. So this is positive correlation, but I wouldn't necessarily call it strong. I would say strong is like 0.8 or higher. So this is just positive correlation. All right, so now that we have that, we're going to put the calculator aside for just a second and look a little bit more in detail about what correlation coefficient is. Because if you didn't join us in our Quizlet game last week, then you might be a little bit confused about what correlation coefficient is, or if you didn't open up that Quizlet game that I shared. So, oh, also, I did forget one thing, part 3. Sorry, we got to go back. So for putting it all together, you go up to y equals and enter the equation you found in part 2. So we'll do 4.6x, and then the x button is right here by the green alpha button, plus 14.8. And then you press graph to ensure that your line matches the data. And it does. So this would be our linear regression for our data. All right. So back to the notes. Oh gosh. So as you can see, it is sometimes tricky to decide if a correlation is strong, moderate, or weak. This would be the case of moderate correlation. The good news is there is a value called the correlation coefficient. So we've already kind of been leading up to this value that helps us determine the strength of a correlation. It also tells us if the correlation is positive or negative. The letter used for the correlation coefficient is R. Don't use R squared. You might see the R squared option there. That's something else that you'll learn about in a higher statistics course. R can range from -1 to +1. You cannot have a value of, say, -2 or +1.8 because those would fall outside of the range of -1 to 1. A positive R value means positive correlation, and then a negative R value means negative correlation. The correlation coefficient R measures the strength of the correlation. So it goes between -1 and 1. I skipped that part. The strength of a correlation between two variables. Okay, and then we talked about how the closer it was to 0, That means the weaker the correlation is. The closer it is to -1 or 1, the stronger the correlation is. So here's a little chart that'll help you. So make sure you write this down. So this would be r equals -1. This is like perfect negative, and this would be perfect positive. Okay, and the closer you get to the middle, the more scattered around the data gets. So it's still this still kind of follows a negative trend, but the data, like if you drew a line through here, a lot of the data is not very close to that line. Okay, whereas in here, it's a little closer. Okay, so it matches a little bit more with the line. And here, there's really no correlation. You really can't tell if the data is going up or down. So that's how you determine correlation. So usually 0.8 is like the cutoff for whether it's strong or not, and then 0.3 is the cutoff for whether it's a weak or not. And anything between 0.8 and 0.3 would be moderate. So this would be strong, moderate, and weak. And then same on the other side, weak, moderate, strong. All right, so now let's do an example. So we've got a history teacher asked her students how many hours of sleep they had the night before a test. The data shows the number of hours the students slept and their score on the exam. Find the line of best fit and state and describe the correlation. All right, so let's go up to here. So I'm gonna go, so we do stat edit because we want to type this data into our table or our list. All right, and then I want to clear this data. So I'm going to go up and press clear and enter. Go up, press clear and enter, and then start typing in the new stuff. So we've got 8778, 877, oh boy. Oh, I just kind of messed it up here. Okay, 8778, and then 657, and then 497. And then over here for L2, we do 83, 86, 74. So 83, 86, 74, 88, 76, 63. And then 90, 60. This is the tedious part, 89, 81. All right, now if you want to be really careful, you would double check all of your numbers with the numbers over here. But you at least want to make sure that the number of items in list 1 matches the number of items in list 2. And it does because I don't have any extras hanging off on either column. And see how, it says L2 11. That means if I go up, L2 10, the 10th item in list 2 is 81. The 10th item in list 1 is 7. Okay, so that matches up. All right, so now we get our scatter plot. So we go to our window settings, and we're going from 4 to 8. So I might go from keep the 0 to 10. That would be good. And then the y values go from, let's see, 60 is the lowest, and then 90 is the highest. So I'm going to go maybe 50 to 100, assuming that you can't get more than 100%. In increments of 2 again. All right, so then press graph. Now this line right here, don't worry about that. That's just the line we drew in the other one. We're going to draw a different line in this case. So that's our data. And now we get our scatter plot. Sorry, not our scatter plot. This is our scatter plot. We get our line of best fit. So go back to stat, but then to get to calculate the linear regression, you go over to calculate. And then down to linreg option 4. And then list 1, list 2, calculate. So there we have our slope, y-intercept, r value. So I'm going to write that down here. So our equation is And we're going to round to 4 decimal places, just like I said. 3, 7, 7, 6, because 5 rounds up, x, and then plus 35.6327. That's our equation. It's a little tedious to write out all of the decimals, but oh well. And then the R value is 0.8831, rounds up to 2. So then I would say that this is a pretty strong positive correlation. Strong positive. Okay, then it says to use the line of best fit to determine the test score if the student slept 10 hours each night. So if, for example, if x is equal to 10, then we could just plug 10 in for x to figure out what his score would be. All right, so let's do that. So obviously, this is a prediction. It might not be true. So we will plug it in and make this prediction. So we go to second quit. We would type in 6.3776 times 10, and then plus 35.6327. So you get, we'll just, since these are rounded, we'll just round this to 99%. So 99% would be that student's test score. So the moral of the story, if you want a 99% on your test, you better get 10 hours of sleep. It's probably not totally true, but do make sure that you sleep well at night. Okay, let's do another example. So assume that during a 3-hour period spent outside, a person recorded the temperature in their water consumption. The experiment was conducted on 7 randomly selected days during the summer. The data is shown in the table below. Create a scatter plot of the data and fit the linear regression, or that fits the linear regression. State what the correlation coefficient is and use it to describe the correlation of the scatter plot. So basically, we're going to follow the same process as we just did. So I'm going to clear this. Oh, I accidentally marked a purple dot. Okay, so go back. Remember, in order to type this data into our list, we go to Stat, Edit. We want to edit our list. And then we want to clear the list. And then we want to type it in. So 99, 85, and then 97, 75, 92, 85, and then 83. Clear that list, and then type in 48, 27, 48, 16, 32, 25, 20. All right, so there we have it. Our numbers match up, and then we're going to make our scatter plot. So let's set a window first. So our x's go from 75 to 99. So how about we go from 70 to 100? Well, let's do 110, just so we don't run out of room. And then the y's go from 16 to 48. So how about just 0 to 50? Okay, and then click on graph. So here we've got our scatter plot, and then let's find our line of best fit. So to calculate the line of best fit, you go to Stat, over to Calc, and then down to Linear Regression. You'll remember this with practice. Go down to Calculate, and then that would be our equation. So let's write it down. So we'll do y equals, I'm just going to write it up here, 1.4512x, because we rounded one up, and then minus 96.8451, rounds up to 2. And then our value is 0.9628. And that is definitely strong positive. All right, and then use the line of best fit to determine the water consumption at 91 degrees. So you would take your equation and plug 91 in for x. Okay, so then we'll do 1.4512 times 91, and then minus 96.8452. Enter, and then we would round this to 35 because that's how much these ones are rounded to. So 35 ounces if it's 91 degrees. And we can be pretty confident in that since the correlation coefficient is so high. For the other one, correlation coefficient was a little bit less strong, so making a prediction using the model is a little bit less reliable. But the stronger the correlation is, the more reliable any prediction will be, as long as it's within the range of data that you have. Okay, that's called interpolation. That's what you're going to learn in the next lesson. If you make a prediction, say you want to figure out the water consumption if it's 110 degrees or if it's 50 degrees, that would be called extrapolation because you're trying to make a prediction outside of the range of data that you created the linear model on. So doing an extrapolation is going to be a less reliable method of making a prediction. All right, so I know that video was a little bit longer, but that's all you have to do today besides to go and try one example on your own and exit ticket. So go ahead and do that now. You don't have any more videos to watch today. You don't have an Edulastic. You just have this video to make sure you really understand, and then go do the exit ticket in Polaris. All right. So thanks for watching. Have a great day.